Hey, what's up guys and welcome back to askNK. Today we're taking a look at how you can control the pivot of your model using geometry nodes. So by default, if you're working in Blender and you like to control the pivot of your model or change it, you can do it in several ways, but this is one of the easiest ways I've found. So you simply change the position of the 3D cursor, go over to Object, go over to Set Origin, and then you can set the origin to the 3D cursor, and with that you can do some pretty rotation. So what we're looking at today is how you can create or change the pivotal point of your geometry by simply taking a look at three major geometries that you would definitely want to use if you're making procedural models. So right here we have a very small graph that details something that is pretty simple. So what you can do with this is, for example, if you would like to scale this particular model, what you can do is go right here where you have the scale and you can scale it. But we wouldn't want to scale this from the center. What if you would like to scale this from a given side? So instead of scaling this from the center, you want to scale it from a given side. Another problem that you would notice if you're making models like this, or if you're working with a simple rig setup like this, is this simple issue or this problem. If you go over here where you have your scale and you choose to play with the scale, you'd notice that you're scaling this upwards. What if you would want the scale to be somewhere right in the center? Because even if you use your transform, or let's say we set this transform all the way back to 1 and use the depth, you still notice you have the very same thing. And at the same time, you would always toggle back with working with these and then going back here. You know, you don't want that. You just want a one-click action, and that is why we're talking about this particular solution today. So starting off, we're going to go ahead and create a brand new one, and what we're going to be looking at is a grid. So let's grab a simple grid and drop that grid right here and pipe this up. So we have that grid going. So with the grid here, the very first thing which you would notice is if we're trying to scale this between the X and Y, we have these values flapping in. Now we would like this value to be either somewhere here, or you would like to change the pivot to be maybe somewhere here or there. So if you're going to be scaling this, so in this case, if I throw in a simple transform and we choose to have the transform right here. So if you're going to be scaling this object at any point, say you want to scale this, you would want it to scale from one point, maybe scale from here over to this part, or simply scale from here over to that part. So to achieve this is pretty simple. The first thing which you need to do is to play with the transform. So what we like to do is to transform this to one part and use that to drive the entire thing. And to get this going, we would need a scale vector. So I'm just going to get a scale and drop that scale vector right in here. And since we're having this object here and we would like to move it to this part, it makes sense to also know that we need to divide it. So if we go over here and divide this by 0.5, so let's go over and divide this by 0.5, nothing happens. But then if we set this to 1 and set this to 1, you would notice that automatically that happens. So from this part, if you choose to scale this, you would now see that the scaling towards this part is more and the scaling towards this part is less. So how can you fully control this? So how you can control it very well is pretty simple. We will need to pipe this up in a way, which means we have to use a simple combine. So I'm just going to throw in that combine vector right there. And what we will want to do is make sure that whatever value that the size has, since the size deals with X and Y, it should also coincide with whatever translation that we have right here, because at this point, this controls the translation. So what we want to get is a simple value. So I'm just going to drop that value node right there, X and Y right there, X and Y right over here. So if we choose to make this 4, you would notice that automatically that moves over to this point. So from here, we can now start doing this. But even at this, you would still notice something, that this is still happening. So how we can get this working exactly how you want it to work is to make a copy of this object, which is our transform, Shift and D, move this over to this part, and then we will drag in a simple divide. So I'm just going to get that divide. So let's get a vector divide because, we're dealing with vectors at this point, and whatever value that is coming out from here, we're going to pipe that up to this vector and divide it. And that is all you need. And finally, you just simply need to go ahead and play with it and you would get what you want. So at this point, you can now have fun doing any of the things that you want. So you want to move this towards this angle, you know, you want to move it towards this angle, you can. Actually, you can even go ahead and make things like butterflies, you know, if this is, or maybe flapping stuff, if this is what you want. So if you hold down Shift and Tab D on the keyboard and move this over to this section, we can connect the geometry here and we can actually get a join node. I think a join node is cool. So we can get a join node, join these two together, connect that right here. And because we are dealing with the y-axis, you know, we want to flip this. I'm just going to put a -1 and that would flip it. So once that flips it, every other thing is history, because if we go over to the rotation, we can make some flappy stuff, okay? So we can make some flappy beds if this is what you are looking for. So if you like to make multiple copies of this, okay, you can make that. If you're thinking about making procedural stuff, like maybe a book closing, a book opening, some birds, some, you know, butterflies, yep, you have that. So with this out of the way, the next geometry that you might have a couple of issues with would be a cylinder. So for this one, I'm just going to get a cylinder. So let's get a cylinder right here. Now, the reason why we're looking at a cylinder is in several instances, once you have a cylinder like this and you start to play with the depth of the cylinder, you would notice it scales in the z-axis. So scaling in the z-axis is one thing, but then controlling how this actually positions itself to the center is another thing. So what we need to do is let's just set this down to what it is. So I'm just going to actually, let's set this to 1. All right. So once we have this there, what we can do is relatively the same thing that we did earlier. So we'll just get a value, drop in that value right here. And remember that one of the things we did was to make a copy. So I'm just going to make this copy, Shift and D, bring that right here, make sure that we have this set back to the original value, which is 1, and we're going to drag this transform right over here, scale the transform, and then we would get a simple combine like we did earlier. So let's get that combine in here, and we're combining X, Y, and Z. So I'm just going to drop that in, and since the value that we would like to drive is the Z-axis, you know what time it is, connect that, and you have it right here. So with this going on, you would notice that, you know, once we're moving this, it's sort of scaling, but it's going upwards. The reason is because we haven't divided this. So divide by 0.5, or, you know, simply use the word scale, 0.5, and there you have it. So if you like the pivotal point to be right here, you can, you know, go ahead and have fun working with it. So this is the second geometry. The last geometry that you might also want to look at is a sphere. So spheres have radius, and how you work with radius is pretty much the same. So what we're going to do here is to get an icosphere, and I'm just going to drop in that icosphere right in here so you guys can see that. And you notice that if I increase the radius of the icosphere, it actually increases to the center. So what we would like to do is to simply do exactly the same thing. So I'm just going to get this radius and throw in a simple value, and with that I can get a simple combine node. And if we drop this by X, we would not get exactly what we want. So let's throw in a simple transform. So if we drop this by X, we will definitely not get what we want. So what we were going to do is to play with all of these values, and the best value actually is Z. So if you do this, you notice it scales towards that point. If you move it over to Y, you notice it scales towards this point. But if you move it over to Z, you notice it scales right in the middle. So you can increase the subdivision, and there you have it. So at this point, if you're thinking about, you know, playing with all of this, these are right here and they are waiting for you to come pick them up and, you know, simply explore with them. And finally, before we go, let's take a look at one more. So we'll go here and get a curve line. So we're just going to use a simple curve line, and I'm going to click and drop that curve line right there. And of course, you can see the direction of the curve line. So it's pointing upwards, and you can make a copy, and we can also make this copy point somewhere else. Now, the thing here is if we choose to convert the curve to mesh and we drop that, we can pipe this as a profile and pipe this as the, you know, the major curve itself and connect it right here. You wouldn't notice anything. The reason why you're not noticing anything is because they have the same direction. So if I set this to 0 and set this to 1, there you go. So you can see this right here. And from here, we can play with the length. And of course, you can play with this. Actually, let's set this back to 1. And yes, you can play with this one as well. Now, the reason why we're talking about this is for those who would prefer to use this method contrary to working with the grid. Of course, the grid has its own, but you know, this is for those who are thinking about exploring with this method as well, this would come in extremely handy. And by all means, if you want to throw in a transform, you can throw in a transform right here, and you can have this working for you. And once you have that, you can, of course, go ahead and make some changes. So you can say, hello, you can make some changes right there. You can also make some changes like so. So if you're thinking about making something like this, yes, you can. So you can have that, increase the length if you want, and you can also increase the length right here. And by every means possible, if you're thinking about resampling, of course you can. So you can throw in a resample, so you can resample this, and this is also going to be very useful. So let's just go ahead and drag this all the way out and turn these on so that you guys can see it. All right, so if we turn this on, you can see the wireframe, and if I simply connect that, yes, you can. So you can see that resampling going in there, and this way you have procedurally created your own grid. So this is for those who are thinking about, making their own grid. Probably you don't want to go through the other grid route. This is one that you might also want to consider looking at. And for those who are thinking about how to plug their procedural models into Unreal Engine and actually work with that, there's going to be a link in the description that'll take you over to AltaMesh, which is an add-on that actually allows you to do that. And for those that are primarily looking for discount add-ons, there is also a couple of discounts that will be in the description, so do well to check them out. Tell me what you guys think about this one in the comment section. And of course, if you like this video or you like something from this, you can go ahead and give it a like, and don't forget to share with a friend. And until I see you guys in the next one, peace.